Welcome back, everyone. In this video, I'm going to walk you through a couple more practice problems spanning all of Chapter 10. So we want to know, for the molecule shown on your screen, which statement best describes the relationship between them. Are they constitutional isomers, geometric isomers? Are they the same molecule? Do they have different molecular formulas, or are they resonance structures? Pause the video, try and figure this one out, and then come back. Welcome back. So, to determine the relationship between them, you want to understand, what do each of these terms mean? Constitutional isomers and geometric isomers have similarities in that they are both types of isomers. And therefore, we're looking for molecules that have the same molecular formula. If they're the same molecule, clearly they will also have the same molecular formula. Resonance structures should also have the same molecular formula. So let's start by first looking at the structures. Do they appear to have similar molecular formulas? They do. Something you should also be able to recognize is that they have, they both have a double bond, and they both have a ring structure. Therefore, they have 2 degrees of unsaturation. And this is important because if they have different degrees of unsaturation, they will not be the same molecule. Okay? So this helps us to see that these probably are related to each other. They are not different molecular formulas, probably. Now, another way to do this is to simply count things out. So if you count up, we can see that we have 6, 7, 8, 9, 10, 11, 12 carbons in both structures. Because they have the same level of unsaturation, because they have the same number of carbon atoms, then that means they're going to have the same molecular formula. It's as simple as that. If we had different number of carbon atoms, or if we had different degrees of unsaturation, then they would not have the same molecular formula. We can also eliminate E as not being resonance structures, because there is no resonance. We don't have the patterns for resonance. We would be looking either for a set of an element with lone pair of electrons adjacent to a double bond, or alternating double bonds and single bonds. And we don't have either of those. Do these have the same connectivity? This is a little bit harder to tell, but what you could do is you could number the carbon atoms in this chain. We see that they both have 6 carbons long and then this blob on the side of them. So these have the same connectivity. They both have a double bond between 4 and 5. They both have a small CH3 group on 5, and then a large ring, 6-membered ring on 5. So they have the same connectivity. They're not constitutional isomers. But can they have geometric isomers? To determine that, we want to look down the double bond and identify the groups. We have hydrogen, and then a long 3-carbon chain, and so this one could qualify for a geometric isomer. And this one qualifies for a geometric isomer because it has a small carbon chain and a large ring. So these both could have geometric isomers. It's a question of, are they geometric isomers? In fact, they are. When you look at the relationship between, let's say, the hydrogen atom and then the small carbon group, in one case they are trans, in the other case they are cis. So they are geometric isomers. All right, now try with this molecule. Do they have the same molecular formula? They do. Count up the number of carbon atoms. We see that we have 6 in the ring, 7, 8, 9, 10, 11, 12. They're both C12 with the same degrees of unsaturation, so they have the same molecular formula. Do they have the same connectivity? No, they don't. How can you tell? Well, do you see how there's this small branch here? And in one case, it's attached to the carbon with the 3-member chain. And in the other case, it's attached to the carbon with the large cyclic ring. Because of that, they have different connectivities, and therefore they are not they are constitutional isomers, not geometric isomers. All right, here's another set of ones for you to try and identify. I'm not going to go through and explain in each of them. So if you do have questions, then come to a help session or ask in office hours or Piazza. But take a minute to try and identify whether these are constitutional, geometric isomers, or neither. The first molecule is neither. These are actually identical to each other. We've just taken the molecule and rotated it. Molecule on the right are neither. These are actually the same molecule. We've just essentially taken this and we've lifted it up a little bit, rotated that bond. These are constitutional isomers. That's because the connectivity of which atom is bound to the other is different. On the right, these are neither constitutional nor geometric isomers. These are actually identical molecules. We've just taken and rotated the molecule around. Bottom left, these are constitutional isomers. And then these are geometric isomers, trans and cis to each other. Let's now take a look at functional groups. So which functional group listed there is not in the molecule shown? This is vancomycin, which is an anti-bacterial drug. Welcome back. Let's see what you were able to identify. Do we have any amides? We do. Here's one amide here. In fact, we have amides spread throughout the molecule. There are many instances there of amides. Esters. See here if we can find any esters. Initially, it does not appear to be so. So let's move on and take a look. Carboxylic acids. We do have carboxylic acids. There's a carboxylic acid there. Do we have amines? We do have an amine right here and an amine right here. And ethers. There are. In fact, there are lots of ethers throughout the entire molecule. So we are missing the ester. Ester functional group looks like what you have there. Now, there is another functional group that we didn't talk about. That is the alcohol. Okay, here's a follow-up question. Which hydrocarbon classes are present? Alkane, alkene, alkyne, and aromatic. Pause the video and try and find the different hydrocarbon classes. So we have two different hydrocarbon classes, the alkanes and aromatic. Aromatic, you can see there are several 6-membered rings with alternating double bonds and single bonds. And then we also have some portions of the molecule that are simply hydrocarbons. There's no functional group that is on them. Here's another one. Which functional groups are found in remdesivir? Pause the video and try and determine this for yourself. Welcome back. So as we go through here, this one's a little bit difficult because you have this group here, which we haven't talked about. This actually is what we call a phosphoester, but you don't need to know that. What you should be able to identify is an amine, an ester, some alcohols, an ether, and then more amines. All right, this is cytosine ribonucleotide. Try and determine the functional groups that are present in this molecule. Pause and determine this and then come back. Welcome back. So again, this is one that is called a phosphoester, but you don't need to know that for Chem 110. We have here an ether. We have some alcohols. These are both amines. And this is an amide. Hey, that's it for this video. Thanks for watching. Have a wonderful day.